Okay, so in this next video, we are going to be working with actually stating the features of absolute value functions. And we're going to look at this with the equation, with a table, and with a graph. So let's first start with the equation. And we're going to be using these values up top to help us. So the very first thing is the vertex. So let's do the vertex. And that is always going to be h comma k. So remember I said that the h value is weird because this negative means we're going to change the sign every time. So since this is positive 3, the vertex is actually going to be negative 3, comma, and then since we're adding the k value, that means the k value is just going to be the same as whatever it is. So this value on the end is negative 1. That means our vertex is negative 3, negative 1. Okay, let's do our slope. And this is really just the slope of the right side. And the slope of this right side is just going to be the number up in the front. So the number in the very front of the absolute value is 2. That means the slope of the right side is 2. Okay, let's look at the x-intercept and y-intercept. So for our x-intercept, this is going to be when y equals 0. But what we're going to do instead of solving for y equals 0, we're actually just going to use Desmos because you can use that on your final exam. So let's go to Desmos and we're going to type in this equation. 2 absolute value of x plus 3 minus 1. Okay, and since we're talking about where y equals 0, that also means where is it crossing the x-axis. So this is crossing the x-axis at negative 3.5 and negative 2.5. So that means that our x-intercepts are negative 3.5 and negative 2.5. You can also see your vertex down here, which was at negative 3, negative 1. So negative 3.5, negative 2.5. Okay, and with the x-intercepts, just remember it's always going to be x equals because we're looking at an x value. So let's do our y-intercepts now. And we're just going to do the same thing. Since we have Desmos, there's no need to really solve it by hand. So we're just going to look for the y-intercept on Desmos. Okay, and the y-intercept is going to be where it's crossing the y-axis. That's also where x equals 0. And that is happening right here at positive 5. So our y-intercept is going to be y equals 5. Okay, let's do our domain, range, and axis of symmetry now. So with the domain, hopefully everyone gets this one right every single time. It's always going to be negative infinity to positive infinity. So that's literally just it for the domain. So let's move on to our range. And since the number in front is positive, that means we're going to go with this very first option. It's going to be k to infinity. So our k value is the number that's added on the end, which is negative 1 in this case. So our range is going to be from negative 1 to positive infinity. Okay, and then our axis of symmetry is going to be x equals h. And I'm going to label this AOS. And it is going to be x equals, and it's going to be the first value of the vertex, or you can say it's the opposite of this number inside of the parentheses. So since this is x minus h, remember that means we're going to be changing the sign. So instead of positive 3, this is going to be x equals negative 3. Okay, now let's look at a table, and then we'll move to the graph down at the bottom. Okay, so with the table, we're first going to start with our vertex. And the vertex is going to be either the highest or the lowest point. But the important thing to remember about an absolute value function is that it's either a V or like an A symbol here. Okay, so it's either going to look like this or it's going to look like this. But the important thing is that after that top point or that low point, it's going to be symmetrical. So we want to look at where these y values are symmetrical here. And we can see it's going 10, 7, 4, 7, 10. That means that this value right here, that 4 that was in the middle, that is going to be your vertex. Okay, so it's a little bit weird, but this value right here is going to be your vertex. 1, 4. And that's because everything is symmetrical around that vertex. So let's look at our slope now. And the slope for this is going to be a little bit different. Remember that the slope is the change in y over the change in x. So that looks like triangle, which is delta y over delta x. And here we're just looking at the change. So you can see, and let's look only at the right side. So we're going to look after this 4 right here. And it doesn't really matter whether this is positive or negative, but let's look at the right side of the function, which would be the bigger x values here. So each time you can see that we're adding 3 on the y values, and on the x values, you're adding 1. So since we're adding 3 and adding 1, this is going to be 3 over 1, which means that our slope is going to be positive 3. You could also say that the slope is negative 3 because that's actually true for the left-hand side. So whichever one, as long as you get the number correct. So it could be positive 3 or negative 3. Okay, let's look at our, let's see where we, oh, x-intercept. All right, so the x-intercept here is going to be where the y value is equal to 0. And this function is a little bit weird because notice the lowest point that it's actually hitting is 4. So since the lowest y value that it's hitting is 4, we actually are not going to have an x-intercept in this case because it's never going to go down to a y value of 0. So there's going to be no x-intercept. All right, let's look at our y-intercept. And this is going to be where x equals 0. So looking on the x side, we do have a 0 right here. That means that your y-intercept, which is a y value, remember, is going to be y equals 7. And we can draw a little arrow up to that. All right, now we're going to do our domain and range. And the domain, hopefully everyone will get it right, is always going to be negative infinity to positive infinity for absolute value functions. So let's move on to our range. And the range is going to be from either k to infinity or negative k to infinity. One way that you can kind of tell which one this is these values are increasing on either side of this 4. So since they're increasing, we're going to positive infinity. Or you could say, whenever we're looking at the bigger x values, these were increasing. So that means that that was our positive a value right here. Okay, so we're going to be going from k to infinity. So our k value, that was going to be the y value of the vertex, which is right here. So this is going to be from 4 to infinity. Okay, and then our axis of symmetry, which we're going to label AOS, that is going to be our h value. So this is going to be x equals h, which is the x value of the vertex. So since the x value of the vertex is 1, that means the axis of symmetry is going to be x equals 1. Okay, let's move on to our graphical version. And hopefully you notice that we've kind of already done the graphical version because we graphed this one in Desmos. And it is getting really bright in here. So let me just turn down this brightness real quick. Okay, that's better. All right, so moving on to our final example here, we are going to be working with first the vertex. And the vertex is either going to be that maximum or minimum point. So that is happening right here. And that is at 2, 1. So our vertex is 2, 1. All right, now let's do our slope. Okay, the slope. All right, and this is just going to be on the right-hand side. So we can see on the right-hand side, you want to go up or down and then left and right. So I'm going down 1, right 2, down 1, right 2, down 1, right 2. So since we're going down 1, that's going to be negative 1, and then right 2, so our slope is going to be negative 1/2. You can think about it as rise over run, but a lot of people have a problem with that because it actually is a little misleading, but you're going down 1, so that's negative 1, right 2. Right is positive, so down 1, right 2 is going to be negative 1/2. Okay, now let's do our x-intercept, and then we'll do y-intercept. Our x-intercept is just going to be where it crosses the x-axis. So that's here and here, which is at the x value of 0 and the x value of 1, 2, 3, 4. So x equals 0, x equals 4. Our y-intercept is going to be where it crosses the y-axis, and this is actually in the same place as our x-intercept. So here's the y-axis, and it was crossing at the y value of 0. So it's going to be y equals 0. Our domain, like I said, hopefully everyone can get this correct, is going to be negative infinity to positive infinity. And then our range, this one is a little bit weird, but we're going from the y value of our vertex. So here it's 1. So it's either going to be from 1 to positive infinity or negative infinity to 1. But here we can see this graph is just pointing downwards the whole time. It's not up in positive infinity. It's not all the way up here. It's all the way down to here in negative infinity. Okay, so this range is going to be from negative infinity to positive 1. All right, and then our axis of symmetry, this is going to be using the x value of the vertex. This is going to be x equals 2. What the axis of symmetry is it means after this point, after this line, x equals 2, this is going through the x value right here, so this is going straight up. If you cut it right there, it would be completely symmetrical on both sides of that. So that's what our axis of symmetry is really doing. X equals 2. Okay, one thing that we did not do that I did right that we're going to do is state whether it has a maximum or a minimum. So let's just look at this for a second. You can really tell by looking at this slope value right here, or you can tell by looking at the range. So if the range is from a number going to positive infinity, that means we have that V look right there. So this would actually be a maximum, or sorry, a minimum if it's V, because you're going down to like a valley. So this was a minimum point, and trying to figure out where to write this. Let's just write it up here. Min. Okay, this one was also going to a minimum point. See how it goes 10, 7, 4, 7, 10. A maximum or minimum is going to be right at that vertex, remember. So this is going down to a smaller point. This is going to be a min. And then our very last one, this one looks like a mountain, so that was going to be a maximum. Okay, and also our vertex was included in this, so let's just do that. Okay, and I just put this extra little note in here. The slope can also be called the rate of change. Hopefully you remember that from Math 1, but that's not going to be something that will usually be asked of you. It's just kind of some extra information. So hope that you guys enjoyed this video. Please feel free to go back and rewatch some other parts if you were confused. And let me know if you have any questions. Bye.